Hi everyone. In this video we're going to look at an example of integration by parts. There are lots of different types of different examples of integration by parts. Some are a little more complicated, some are simpler. This one's a little simple, but not like the most basic. In general, integration by parts is reversing the product rule from differentiation. So here I want to take the derivative, or take the antiderivative, or find the antiderivative of x times the natural log of x dx. And so I want to look at this as a product of a function with the derivative of another function. Okay. Typically we call these functions u and v. So I want to think of this integrand as some function u multiplied by the derivative of some function v. In deciding which is which, u needs to be a function that is fairly easy to find the derivative of, because I'm going to have to find du. And dv needs to be a function that's easy to integrate. Now, I can integrate natural log of x, but it's not one that I know off the top of my head. But finding the derivative of the natural log is pretty easy. So I'm going to choose u to be the natural log of x, and dv to be x dx, because it's easier for me to find the derivative of natural log and to find the antiderivative of x. Okay, so if u is natural log of x and dv is x dx, then the derivative of u, or differential of u, is 1 over x dx, and an antiderivative of dv is 1/2 x squared. So now I have the 4 pieces I need in order to use this formula for integration by parts. So first, we need to multiply u times v. So that'll be natural log of x times 1/2 x squared. And then I need to subtract off the integral of v du. So in this case, that'll be the integral of 1/2 x squared times 1 over x dx. Because I have an x squared in the numerator and an x in the denominator, when I multiply those together, I just get a single copy of x. And I pull that constant multiple of 1/2 to the outside of my integral. So my integrand is simplified a little. Now, and this is really one of the reasons we want to use integration by parts, I'm left with an integrand that I know how to integrate. So I've taken something that is more complicated, that I don't know how to find the antiderivative of, and I've simplified it to something that I do know how to find the antiderivative of. So the 1/2 x squared natural log of x has already been integrated, so I just copy that down. The antiderivative of x is 1/2 x squared, or the integral of x is 1/2 x squared. And then I put down my plus c because this is an indefinite integral. 1/2 times 1/2 is 1/4, and so there is my indefinite integral for x natural log of x. And this was done using integration by parts, which is really reversing the product rule from Calculus 1. And the tricky part is identifying the u and the dv, and you always want to pick u to be something that's easy to find the derivative of, that gets simpler when you take its derivative in a sense. And the dv always has to be something that it's fairly easy to integrate. Okay, if I had picked dv to be natural log of x, that would have been actually really hard. Okay, so that's an example of integration by parts, and there are lots of variations on this, but in general, that's the basic routine. That's the basic pattern for how you carry out this type of problem. Okay, in the next video, we're going to look at partial fraction decomposition. And as you notice, the example we're looking at is one that we've integrated before.